All right, so we should have our vocab words filled out there, and then now we are going to look at identifying arithmetic sequences. So remember, arithmetic sequences are when we are constantly adding new terms. So here, we just have to check, are we going up by the same amount every time? So from -2 to -3, we go up by 2, up by 2, up by 2. So yes, we have an arithmetic sequence. So yes, and I'm even going to add that the common difference is 2. Same idea looking at these next ones here. How many new tiles are we adding? So in the X example, from this one to this one, we have 4 new tiles. From here to here, we once again added 4 tiles, one on the end of everything, so going up by 4. So this is yes, because they're going up by the same amount, 4. Here, we added 3 new tiles. Here, well, if we think of this little triangle as the shape from the last time, that means we added 1, 2, 3, 4, 5 new tiles. So this one is a no, because we did not add the same amount every time. So I'm going to write that here, added different amounts. All right, so now for the one that is arithmetic, so for the one that makes an X, write a rule for the pattern. Use the table to help you write a rule. So I'm going to start with the first term. I'm just going to kind of skip this 0 term. We'll talk about that. Actually, I'm not going to cross it out just yet, but we'll kind of work backwards to get that one. So first term there was 1, second term there was 4, third term there were 9, 5, because the one in the middle. Then we added 4 and got 9, and we added 4 and we'd get 13, and if we add 4 again, we would get 17. Okay. So the equation is going to look like a to the n power equals whatever the difference is times the term number plus the 0 term, a to the 0. So that's that one we haven't figured out yet. But if we kind of use the pattern that these are all going up by 4, so if we're adding 4 every time, if we just work backwards 1, well, 1 minus 4, working backwards, so I'm subtracting, we get -3. So to come up with the equation, we have a to the n, so just whatever term number we're trying to find, equals the difference, well that's 4, times however many terms there are, plus a to the 0, which is -3. Use your rule to find the number of term tiles in the 18th step. So just like we were kind of doing with those rules on the first page, we want the 18th term, so a to the 18th equals 4 times 18 minus 3. So we just plug in 18 for this n and this n. So a to the 18th equals, and just type that in your calculator, and we should get 69. All right, so let's take a look at the next page where we're going to be talking more about these rules here. So there's 2 ways we can write the rule for an arithmetic sequence. So the way I kind of just showed it, a to the n equals the difference times n plus the 0 term. So you're always going to have to work backwards a little bit to get the zero term, the term before the first term. And another way to kind of think of that is the y-intercept. And it's before the first term, which is why it's not, we can't just use the first term because that's when x is 1. So this d is always going to be the common difference. And this a0 is not in the sequence. All right, and then the other way we can think of this rule, and they kind of go together. I'll often use this second way and then solve for the first way. We have the difference again, d, and now we do n minus 1 plus the first term. So this way is a little bit easier because you're able to plug in the first term. You don't have to work backwards to get the zero term. But a lot of times I'll kind of use this, solve, like simplify it with distribution, and then it'll end up looking like the one I have in blue here. So the common difference is still d, and a1 is the first term. All right, let's look at a couple examples. So write a rule just in general terms, and then plug in 19 and find the 19th term. So here we first have to, how much are we going up by? So 2 to 9, we're going up 7. 9 plus 7, we do get 16. I'm just kind of checking our pattern, and yep, we're going up by 7. So 7 is the difference. So I'm going to use the second formula to kind of figure out our formula here. So now we've got the a to the nth term. Our difference is 7, n minus 1, plus the first term, so a1 would be 2, so plus 2. So now I'm going to simplify this by distributing the 7. So 7n minus 7 plus 2, we get 7n minus 5. So I would use that rule. That's going to be the simplest we can do for our rule here. Now we want to plug in 19. So 7 times 19 minus 5, and we should get 128. All right, next one. First, let's figure out our difference. So here we're going down, so it's going to be negative, and we're going down by 12s, it looks like. 45 minus 12, yeah, we're going down by 12. So that is our difference. So a sub n equals negative 12, n minus 1, and then the first term is positive 57. So once again, I'm going to distribute this 12. So negative 12n, negative times a negative, positive 12 plus 57, and get the formula is negative 12n plus 69. If I plug in 19, a19, so negative 12 times 19 plus 69, plug that all in your calculator, and we should get negative 159. All right, just a couple left here. So on this checkpoint, write a rule for the nth term and then find a22. So same steps we were just doing. So let's find the difference. So here we went down, so it's going to be negative. Negative 4 is our difference, and check it again. Oop. Negative 4, yeah. So a(n) equals negative 4 n minus 1, sorry, and then plus the first term. Let's simplify that. Negative 4 times n plus 4 plus 9, negative 4n plus 13. All right, last one. So given a rule and just one term, or write a rule given just one term and the common difference. So they're not giving us the whole pattern. They're only giving us one, and we need to figure out the rest. So I'm going to write the general form here. A sub n equals d n minus 1 plus a1. So now we know the 11th term. So we know when n is 11. We also know what d is. So I'm going to plug in 11 for n and 5 for d. So the 11th term, we've got 5 here, we've got 11 here, and plus the first term. So I don't know what the first term is yet, so we're going to leave that. But this A11, I do know how much that is. A11 is 41 up above. So instead of putting A11, let's plug in 41. So now if we simplify this down, we've got 41 there, 5 times the parentheses simplifies to 10, so we have 50 there, plus a1. So now we've got something we can solve for. So we have a1 equals negative 9. When we plug this all back in to our form up here, we get an equals the difference. I'm going to plug in 5. I'm going to leave this n and 1 because we want the generic form for the rule here, and then plus negative 9. So let's actually do minus 9. We could leave it like that. I am going to simplify it a little, distribute that 5. So 5n and then negative 14 when we combine those terms. So our rule, a to the n equals 5n minus 14. All right, so for the rest of the hour, you need to look at that homework sheet. You should be able to complete most of the first page. I think a couple at the bottom we're not quite ready for. And that's it. See you guys on Monday.